Chapter 7, Lesson 1, Coordinates in Space. So up until now, we've been talking about two-dimensional distance, so along the same plane. So how far is it from here to Independence is two-dimensional because it's on the same line. Now we're going to be talking about coordinates that are in space, so three-dimensional. So when we are doing distance in space or three-dimensional distance, we're going to be given coordinates that have an x term, a y term, and a z term. And we're going to be given two coordinates that have an x, y, and z term. So we're going to follow the same part of the distance formula we were doing before with your x's subtracted and your y's subtracted. And now we're going to add in that third element of your z's subtracted and squared. So on this first one, I'm going to go ahead and label x1, y1, z1, x2, y2, z2. So when I set up my square root, I'm going to have -1 minus 1 and squared plus -2 minus 2 close and squared plus -3 minus 3 close squared. So I have 4 plus 16 plus 36, which is square root of 56. And the square root of 56, calculator, square root of 56 is 7.5. So one more here, I'll have 2 minus -1 closed squared plus -3 minus 0 closed squared plus 8 minus 5 closed squared. So I have the square root of 3 squared plus 3 squared plus 3 squared, 5.2. All right, so vectors work the same way then. When you are asked to find the magnitude, remember that's the same thing as the distance. And it says that each point in the initial point is 0, 0, 0. So this first one would just be 2 minus 0 squared plus 2 minus 0 squared plus 2 minus 0 squared, which is square root of 12, 3.5. On number 7, it would be the square root of 0 minus -1 squared plus 0 minus 0 squared plus 0 minus 3 squared, which is 1 plus 9, and the square root of 10, I believe, is 3.1, 3.2. This one wants us to add the vectors, and so I'm going to just add like terms. So for the u plus v vectors, I'm going to do 4 plus -3, which is 1, comma, 5 plus 0, which is 5, comma, 8 plus 5, which is 13. Same thing on number 11. I have -6 plus 0, which is -6, 2 plus -1, which is 1, and 1 plus 2, which is 3. An airport is located at the origin, which is the center of the XYZ coordinate system. 2 airplanes are located at 5, 6, 2, and -4, 3, -5. Which airplane is located farther, which means we're going to be talking about distance from the airport. So for A, I'm going to be doing the square root of 5 minus 0 squared plus 6 minus 0 squared plus 2 minus 0 squared, which is square root of 5 squared plus 6 squared plus 2 squared, 8.1. And for plane B, -4 minus 0 squared plus 3 minus 0 squared plus negative 5 minus 0 squared is 16 plus 9 plus 25. 7.1. So it says which one is farther? Plane A. How much farther? 1 unit. About. A third airplane travels from the airport and on a course that can be described by two displacement vectors, u and v. The first vector u has components 7, 2, negative 7. The second vector v has components 5, 3, negative 2. What are the components of the vector that represents the path of the airplane from the airport to the terminal point of v? So I want to add my two displacement vectors. So that would give me 12, 5, negative 9.